Hi Year 10s, today we are doing sketching parabolas by completing the square. And one key thing for this is when you complete the square, the equation turns into turning point form. So you can read off the turning point just automatically. So copy down this one page, it's exercise 7D by the way. Copy down the notes just here and then I'll just get straight into the examples. Alrighty, good job. Okay, so from the notes, a quadratic is the generic form of a quadratic equation is y equals ax squared plus bx plus c. Now, if we complete the square, and hopefully you remember that from a few topics ago, we get it into this form, and this here is called turning point form. So to give you a few reminders, the a out the front, if that number is like 5, it makes it a narrower parabola. If that number is less than 1, so a half, it makes it wider. The h inside here, if it's negative, it moves it to the right. It moves the whole parabola over. So I always look at the turning point and move the turning point to the right. And if it's a positive, it moves it to the left. And this k value at the end, if it's positive, it moves it up. So the turning point gets moved up. And if it's negative, it moves it down. So hopefully you remember all that. One thing we forgot, if it's a negative out the front here, it makes it an upside down parabola, or they call it inverted. Or if it's a positive, it's an upright parabola. Alright, so the steps involved. Find the turning point from the equation. So when it's in turning point form, you can read off the turning point. I'll help you with that in a minute. Then find the y-intercept, let x equal 0. Find the x-intercepts, let y equal 0. And remember here, there could be 0 intercepts, there could be 1, or there could be 2. So always keep that in mind. Alright, let's start. So for y equals negative 4, x minus 1 squared plus 16. Before you can answer finding the turning point, let's look at a few features. We've got negative, so we know it's a negative parabola, it's upside down. Since it's a 4 out the front, it means it's narrower. So if that was a normal parabola, this one is narrower, so it's like that, because it's a 4 out the front. X minus 1 squared, which means it moves it to the right one spot, moves the turning point one spot to the right, and a positive there means it moves the turning point up 16. So just from this, it says find the turning point, and we know it's 1 across, so the x value is 1, and it's 16 up, so it's the y value is 16. So the coordinate of the turning point is 116. We can read it off just straight from there. And it also said, and state whether it's a maximum or a minimum. So remember, because it's a negative, it's an upside down parabola, which forms a maximum value. So you've got to say it's a maximum as well. And remember, if it's a normal one, an upright one, and it's a minimum value. Alright, y-intercept. So I'm just going to do this over here. So the y-intercept, let x equal 0. So we get y equals, I'll write the equation out and then we can just do it from here. X minus 1 squared plus 16. So y-intercept, let x equal 0. I love writing this out. It shows the teacher what I'm doing and it keeps it nice and sort of set out nicely. A lot of people don't do that and then they say, oh, how do I do it? It tells you what to do. Let x equal 0. So we're going to substitute 0 into this equation. So we get negative 4. 0 minus 1 is minus 1 squared plus 16. Now just working it out, we get minus 1 squared. Minus 1 times minus 1 is positive 1. Plus 16, so be careful with positives and negatives. Negative 4 plus 16, y equals 12. So my y-intercept is 0, 12. I always like writing my coordinate there so I don't get confused. 0, 12. Next one, let's find the x-intercepts if they exist. Let y equal 0. Okay, here's my equation. Let y equal 0. So I've got negative 4, x minus 1 squared plus 16 is equal to 0. I like having my 0 on the right hand side. It's just preference. Now, the first thing we can do, there's different ways you can solve this. If you wanted to get the 16 to this side, that's one way to do it. Let's just do that. So we've got negative 4, x minus 1 squared equals negative 16. Now we could divide both sides by negative 4. So divide by negative 4, we get x minus 1 squared equals negative 16 divided by negative 4 is positive 4. Okay, there were other ways to do it. You could, I think the textbook multiplies both of these terms by -1. So this becomes a positive, and that becomes a negative, equals 0, and then they work it out from there. But there's lots of ways to do it. Okay, now what we need to do is, we've got, this whole thing is squared. So how do you get rid of a squared? You do the opposite, so you square root both sides. So this becomes x minus 1, and this square root of 4 is 2. However, that is not the complete answer. Square root of 4 is actually plus or minus 2, because when you remember 2 squared is equal to 4, and -2 all squared means -2 times -2, which is also positive 4. So from now on, whenever you square root a number, there's 2 answers. It's positive and a negative. All right, now we do this. So we can solve x minus 1 is equal to positive 2. We'll also write here x minus 1 is equal to -2. We'll get our 2 answers. So x equals plus 1 to both sides, x equals 3, and plus 1, minus 2 plus 1 is minus 1. So we've got 3, 0, and we've got -1, 0. And there we have it. We've answered the question. It said find all the values, and if we wanted to, we could sketch it. We may as well. It didn't ask for it in the question, but we could sketch our graph as well. So there's x and y. Let's just see if it makes sense. It's always a good idea to sketch. So we've got our intercepts are at -1 and 3. Our x-intercepts. Our y-intercept is 0, 12. All right. And our turning point is 1, 16. So our turning point is 1, right in between those two, so we know it's a sensible answer. And 16's up about there somewhere. It's up there. Okay, so we've got these 4 points. And we know it's a negative parabola, so that this makes sense. So we can draw our parabola like that, and that is a very sensible answer. So our turning point's up there, our y-intercept and our x-intercepts. We've labelled all the main points, and we've even done a sketch. So good job, everyone. All right. Now, the last example was already in turning point form for you. This one says sketch by completing the square. So you've got to remember how to complete the square, and by doing that we get it into turning point form. So y equals x squared plus 6x. Okay, the middle term is 6. So hopefully you remember this. You halve it and square it. Half of 6 is 3, 3 squared is 9. So you go plus 9. That now creates a perfect square. We've also got, because you've added 9, you must subtract 9, and we've also got a plus 15 there as well. I leave a little gap so I can work this bit out first. So this bit here as a perfect square is x plus 3 all squared. And then here we've got minus 9 plus 15, which is plus 6. Alrighty, so now we've got that equation in turning point form. It just says sketch by completing the square. So what important points do we need? We need firstly the turning point. The turning point is positive 3, so 3 that way to the left and 6 up. So my turning point is -3 and 6. And it's worthwhile to say, is it a maximum or minimum? So this time it's an upright parabola, so it's going to make a minimum. Alright, next bit, y-intercept. There's always a y-intercept. That occurs when x is equal to 0. So 0, 0, 15, that was really easy. So y equals 15. So my point is 0, 15. Now, we can sit there and try and work out the x-intercepts, let y equal 0, but sometimes it's a good idea to have an idea of what our graph looks like, and I'll show you why. So we've got our x and y axes there. Okay, so what have we got so far? We've got our turning point is -3 and 6. So our turning point's there. We know it's an upright parabola, and our y-intercept is at 15. So I didn't make it high enough, so it's somewhere there. So if we do a little sketch, didn't ask for a sketch just yet. Well, it says sketch at the end. But there's our sketch. We've got our y-intercept at 15. We've got our turning point at -3, 6. Are we going to waste time trying to work out our x-intercepts? No, we're not, because there are no x-intercepts. Because we can see from our turning point and the fact that it's an upright parabola that there's no x-intercepts. They don't exist. Let's try and work it out just in case. So if we didn't realise that straight away, let's try and work out the x-intercepts. Let y equal 0. So we get x squared plus 6x plus 15 equals 0. Or you could actually just use, you try and factorise that, it won't work, but you could use x plus 3 squared plus 6 equals 0. So let's subtract 6 from both sides, see what happens. Equals negative 6. Okay, so we have to square root both sides. So we get x plus 3 equals the square root of negative 6. Is it possible to get the square root of a negative number? No, it is not. So this is not possible. So when you get to this stage, if you didn't realise already, there's no x-intercepts, you should realise using your maths that it's not possible. You can't get the square root of a negative number. So there it's telling you there are no x-intercepts. But in a test, save time by doing a little sketch. Have an idea of what your graph looks like to save you time. You do not need to do the x-intercepts if they don't exist. Excellent. And so we only do the ones with an even number in the middle, the normal classes, because you halve it and square it. And the extension class will be doing other stuff with Mr. Kendrick. So anyway, try 7D everyone, page 524, questions 1 to 10. And I'll see you soon. Don't forget, smash that like button.